Good morning students. Welcome to the YouTube channel of Little Flower School Rapti Nagar. I am Amit Kumar, your computer science teacher, and this is the third video lecture for class 11th A and 11th B. In our previous two lectures, we have actually discussed about class 11th complete syllabus and of course the numbers and interconversion of numbers. In my previous two tutorials, I promised you that I will provide you a query submission link, a Google form where you can submit your queries, which I will raise, of course, which definitely I will try to resolve in the upcoming video lectures. So you can get the link of the query submission form right in the description, and you can submit your queries by entering your Gmail ID. There you have to provide your name, you have to choose the section in which you are right now. You can opt according to whether you are going for bio or going for arithmetic, and then you can submit your question over there, and of course you can also upload any image if you want to upload along with it. So what about today's lecture? Actually, in today's lecture we are going to discuss about numbers arithmetic. That means we are going to perform arithmetic operations on numbers. So what's so new about it? We all know how to perform plus, minus, divide and multiply on numbers, but this time we are going to do it on binary numbers. So today we will learn how to perform addition, subtraction, multiplication and division on binary numbers. That means binary arithmetic. Okay, so let's start. What's there in binary numbers arithmetic? So we will start with binary addition. Okay, so actually binary addition is one of the easiest arithmetic operation performed on binary. You should be careful about the carries, that's it. So whenever you have to provide the carry, you have to be careful about it. But where you will provide carry? So if you can relate it with decimal number system, the largest number, whenever you get the largest digit, that is 9, and if anything is added to it, okay, anything is added to 9 and especially 1, okay, so then you have to do the carry. Even in case of 8, if 2 is added or greater than 2 is added, you have to do the query. So simply, that means if anything is greater than 9, then definitely you have to do the carry. Similarly, in binary number system, if anything is added to 2 or anything is added to 1, I should say, then definitely you have to do the carry, because 1 plus 1 is 2. And in binary, 2 is represented as 1 0. So the single digit number in binary are only 0 and 1. 2 is represented in 2 digits, 3 is represented in 2 digits, then 4 is represented in 3 digits. You know that. So you should be careful about these things, these carries, and let me tell you whenever you have to do the carry. For example, simple addition like 0 plus 0 will be 0, no doubt. 0 plus 1 will be 1, and simply 1 plus 0 will also be 1. Now in case 1 plus 1 is given, okay, 1 plus 1, it's 2, and here is the first place where you need to give the carry, right? Similarly, if anything is added to 2, for example 1 0 plus 1, okay, 1 0 plus 1, so it will be 1 1. It's not 11, it's 1 1, which represents 3 in decimal. And similarly, if anything is added to 1 1, okay, so 1 1 is 3, 3 plus 1 is 4, so that is 1 0 0. Now how this is done, okay, how this is done? So for that only I am telling you these basic 4 operations. The basic 4 is 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1 0. So this is where you have to take care. 1 plus 1 is 1 0. Okay, so now let's perform some binary addition. Let's perform normal binary addition without any fractional point in it or any fractional part in it. Number is 110 110. So 110 110 plus 1100. Okay, so we'll simply add it. We have to be careful about the digits, so their place is just like in decimal number system. We have to be careful about the places. These leading left places can be filled with 0 if no digit is there. Now you simply add 0 plus 0 is 0, 0 plus 1 is 1. Now 1 plus 1 is 1 0, so we will write 0 over here and 1 will go carry. Now 1 plus 0 is 1 and 1 plus 1 is 1 0. So 0 will be here and 1 will go carry. Now 1 plus 1 is 1 0 and 1 0 plus 0 will be 1 0 itself. So 0 will be here and 1 will go carry. Now 1 plus 1 is 1 0, 1 0 plus 0 is 1 0 itself. So this is the number. So you see there were three places over here where we do the carry. Okay. Now we will not do binary addition with more than two numbers, but in case if we have to do binary addition with more than two numbers, then make sure you are clear about binary numbers like 2 plus 1 is 3. So in binary 1 0 plus 1 is 1 1. 3 plus 1 is 4. So in binary 1 1 plus 1 is 1 0 0. And 4 plus 1 is 5. So 1 0 0 plus 1 is 1 0 1. So you have to be careful about these things if you are adding more than two numbers in binary addition. Now binary addition can be given with help of fractional part as well. So there also you have to be careful about the position of the digit. So the next number that we are taking for binary addition is having the fractional part, and the number is a bit lengthy. So 1 0 1 1 0 1 1 1 1 0 1 1 0 1 1 1 point 1 1 0 0 1 1 1 0 0 1, which is added to 1 0 1 0 0 1 0 1 0 0 binary point 1 0 1. Okay. So I told you about the positions, like after binary point there are 3 digits. Here also after binary you will write those 3 digits, and then after the rest 2 digits we will write 0 over there. Now here are 5 digits before binary point, so 1 0 1 0 0, so it is 1 0 1 0 0, and the rest of the places we will keep 0 over there, and we can now add them. Now 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 0 will be here and 1 will go carry. Now 1 plus 1 is 1 0 and 1 0 plus 0 is 1 0 itself. So 0 will be here, 1 will go carry. 1 plus 1 is 1 0 again with 0, so it is 1 0. Now be careful over here. 1 plus 1 is 1 0, that is 2, and 1 0 plus 1 is 1 1, which is 3. So 1 will be here and 1 will go carry. 1 plus 0 is 1 and 1 plus 0 will be again 1, so it will remain 1 only. So nothing will go carry. 1 plus 1 is 1 0, so 0 and 1 carry. 1 plus 1 is 1 0 plus 0 will be 1 0 itself, 0 and 1 carry. 1 plus 0 is 1 and 1 plus 0 is 1, so it will be 1 only, and 1 plus 0 is 1. So this is our result, 1 1 0 0 1 1 0 0 point 0 1 1 0 1. So whenever you are doing binary addition, the place where you are doing the carry, that is the place where you have to take care. Rest, I told you, it's one of the easiest arithmetic operation performed on binary numbers. Now the next operation that we are going to see is binary multiplication. Now a few of my students are saying that, sir, binary multiplication is much easier than binary addition. So if it is, then it's good, but actually in binary multiplication you have to perform two things. You not only have to perform the multiplication, but you also have to do the addition part. So the process of multiplication is as similar as normal arithmetic or normal multiplication of decimal numbers, but the thing is here only we will deal with 1 and 0. So let's see the 4 possible results with multiplication. Now 0 multiplied by anything is 0, so 0 and 0 will be 0 itself, 0 and 1 will also be 0, and 1 multiplied by 0 will also be 0. So there is only one possibility for getting a 1 in multiplication, that is 1 multiplied by 1. This is the only case when you will get a 1 in binary multiplication. So let's perform a binary multiplication. Let's take two numbers for the multiplication. Let's take 1101 multiplied by 101, or multiplied by 10, let it be a smaller one. So you will do the multiplication as like you were doing in mathematics. So first of all, you will take this place, units place, which you say in mathematics, and multiply it with all the digits. Because it's 0, hence all the 4 digits will result into 0. Okay, and now we will multiply with 1, but before doing that we will put a cross over here, and now we will do the multiplication. Now 1 multiplied by anything will be that number itself. So 1 0 1 1. So now we will do the addition part. Now 0 added to 0 will be 0 itself. 0 or 1 or 0 added to 1 will be 1. 0 plus 0 will be 0. 0 plus 1 will be 1, and 1 there. So 1101 multiplied by 10 will be 11010. Let's do one more multiplication, and this time a bigger one. Not too big, but let's see, 11011, and let it be multiplied with 101. Okay, fine. Now first of all, 1 will be multiplied with 5 digits, so they will be as it is. Okay, now we will put a cross over there. Now 0 is multiplied with 5 digits, so 5 zeros will be there. Now 2 crosses, and now 1 will be multiplied with these 5 digits, so it will be 11011. Now finally all that you need to do is to add them. Now 1 added to 0 will be 1, 1 added to 0 will be 1, 1 added to 0 will be 1, 1 plus 1 will be 0 1, 0 will be there and 1 will go carry. It should be 1 0, not 0 1. Now 1 plus 1 will be 1 0, added to zeros will be 1 0 itself, so 0 1 carry. 1 plus 1 is 1 0 again, so 0 1 carry, and 1 plus 1 is 1 0. Hence product of these two numbers is 1000111. So this is how you are going to perform binary addition and binary multiplication. Now the only confusing part, because we cannot do division until unless we learn subtraction. So the only confusing part in binary arithmetic is related to binary subtraction. And I quote it, confusing part, it's not difficult at all. It's not at all difficult. The thing is, we get confused because we are habitual of doing any arithmetic operation in decimal number system, and we were doing it since our childhood. We learned binary number systems now, and now we are learning the arithmetic operation on it. So definitely it's going to be confusing for us, just like the simple subtraction of decimal numbers were confusing for us in junior classes. But with our practice, we learned it, and now it's very easy for us, right? So similarly, if we will practice on binary subtraction within few months, it would be very easy for you. And there are 3 different ways to perform binary subtraction. It's not like there is only one way to do that. So in case the first methodology, the first method that I am going to tell you for performing binary subtraction, you find it difficult to perform, you can opt the other 2 options also. So today I will tell you 3 ways through which you can perform a binary subtraction. Now the point to be noted over here, like while you are doing the subtraction, the first number should always be greater than the second number. Then only you will get a positive difference. If the first number is smaller than the second number, then you will get a negative difference, right? So here, while performing the subtraction, what about the sign? How to put the sign? Shall we use simple minus or plus symbol in front of the number to represent positive or negative? So that's not truth. Actually, in the next chapter, which is based on encoding, we are going to understand how negative numbers are represented in memory with binary numbers, how we represent negative numbers. So but today also I will tell you one of the way to write down negative numbers, and that question will come while performing binary subtraction. So let's see binary subtraction first. So for performing binary subtraction, you should know when you are in need of borrowing numbers, because whenever we do subtraction, there are situations where we need to borrow numbers. For example, if I am doing 0 minus 0, I need not to borrow anything, it will be 0. If I am doing 1 minus 0, again I need not to borrow anything, it will be 1 minus 0 is 1. If I am doing 1 minus 1, definitely it will be 0. So these three binary subtraction cases are very clear, because in all these three cases, either the first number is equals to the second number or first number was greater than the second number. But the problem arises when the first number is smaller than the second number, like here 0 minus 1. Now how you are going to perform this? Okay, to perform this, we are going to take a number from or a digit from a digit preceding this digit. For example, if 0 is there and if any number is preceding it, then we will borrow some value from there. Okay, and to understand it, let's say, so we are going to borrow whenever we are subtracting from 0. It's obvious, because there are only two numbers, 0 or 1. So if we are subtracting from 1, it's not an issue. But if we are subtracting from 0, it's an issue. Okay, it's not possible. We cannot subtract anything from 0. So in that case, we have to borrow a value, we have to borrow a number. So just for your revision, I am showing you how do we borrow in mathematics. For example, in mathematics, number is 546 and 463. Suppose this is the number. Or let it be 467. Okay, so now while subtracting, you cannot subtract 7 from 6. It's obvious, you cannot subtract that. So what you will do, you will try to take value from a previous number. So if you will take value from here, so 4 will reduce to 3. And when 1 is coming here from the previous number, if 1 is coming here, it's not like 1 is coming here, it's 10 is coming here, right? So this will become not 7, it will become 16, because we will just put 1 before it, and then we will subtract 7 from 16. That's what you do, right? So what would be the output? 9. Fine. Now again, if you want to subtract 6 from 3, that is not possible. So again you will borrow. This will become 4, and instead, and 1 will come here, and 3 will not become 4, 3 will become 13. So 1 is simply added in front of it, and then 6 is subtracted from 13, and definitely it will become 7. Now 4 subtracted from 4 is 0, so 79. So 467 subtracted from 546 is 79. Okay, you know that, and I also know that you know this subtraction, but I wanted to tell you that what happens when we borrow. So similarly is the case when we do the subtraction with binary numbers. Now imagine if we are subtracting, suppose we are subtracting 2 from 5. If we are subtracting 2 from 5, so 5 is 101, and if you want to subtract 2 from here, so it will be 10. Now to perform the simple subtraction, what you will do, 1 minus 0 is fine, it will be 1, no issues. Okay, but now you have to subtract 1 from 0. How you are going to do that? So now you have to take borrow. So if you will take borrow from the previous one, 1 will reduce to 0, and 1 will come here. So this 1 will be added to this 0, but it will be not like 0 plus 1. 1 will be simply added in front of 0 like this. So it will become 10. And what is the value of 10 in what is the decimal value of 10? The decimal value of 10 is 2. And if you will subtract 1 from 2, what you will get? 1. So definitely whenever you are borrowing, you are doing this subtraction and you are actually borrowing a value from the previous one, definitely it will turn out to be 10, and 10 minus 1 will result into 1. Okay, so 0 minus 1 will result into 1 only if we are borrowing a value from the previous one. Okay, fine. So it will become 10 minus 1 will be 1. And if you can check it out with decimal value, like decimal of 101 is 5, decimal of 10 is 2, and if you will subtract 5 minus 2, what you will get? 3, and which is actually decimal of 11. Okay, so this is the place you have to be careful while borrowing, and this is the place where students commit mistake. I hope you understood this, and let's do some more subtraction, and then I will tell you 2 other ways through which you can perform binary subtraction. So let's proceed and let's see binary subtraction with one more number. So the next number that we are going to deal is 1100101, 1100101, and we are going to subtract 4 times 1 and 0 from here. So 4 times 1 and 0 from this number. So we are going to do that. And these places are vacant, so I am just putting 0 over there. Okay. Now let's do the subtraction part. 1 minus 0. So it will be 1. No issues. Now 0 minus 1. You can't do that. You have to take. So it will become 0. And this will become 1 0. So 1 0 minus 1 is 1. Now this is already 0. You have to take borrow from the previous one. It is already 0. So it will borrow from here. And it is also 0. So it will borrow from here. So this will become 0 and this will become 1 0. Right? So from 1 0, if I am borrowing something, imagine if I am borrowing something from 2, right? 2 will reduce, and to which number it will reduce? It will become 1. So if I am subtracting anything from 1 0, it will become 1 and this will become 1 0. But I have to do one more borrow, so this will become 1 and this will become 1 0. Right? So from here I started the borrowing. Now 1 0 minus 1 will result into 1. 1 minus 1 will result into 0. 1 minus 1 will result into 0. 0 minus 0 will result into 0. And 1 minus 0 will result into 1. Okay. So this is the subtraction of the result of the subtraction. You can verify whether you have done correct or not by adding the last two if you will get the first one. For example, let's do the verification. So this is the verification, whether the subtraction is done correctly or not. So I am getting the result, writing down the result over here, and then I am adding this one. So it is 1 1 1 1 4 times, 1 1 1 1 and then a 0. So 1 plus 0 is 1, 1 plus 1 is 0 and 1 carry, 1 plus 1 is 1 0, 1 0 plus 1 is 1 1, 1 and 1 carry, 1 plus 1 is 1 0, 0 and 1 carry, 1 plus 1 is 1 0, 0 and 1 carry, 1 1. So this should be the first number. Let's check it out. Is the first number 1 1 0 0 1 0 1. It's the first number. So it is correct. So here is the case where if you are borrowing from the previous number and it is 0, so it will go beyond that. It will try to borrow it. And whenever we are borrowing from 1, 1 becomes 0. And if we are borrowing from 1 0, 1 0 will become 1. So we will just reduce 1 from it. Okay. So that you have to be careful about, and you can easily verify whenever you want to verify. You can easily verify by adding the last two, the result and the number preceding it, and you will, if you are getting the first number, definitely you have done the correct subtraction. Okay. Let's do one more subtraction, but this time with fractional part. Okay. And then I will tell you the other two ways through which you can perform the subtraction. So this was the first way. You can perform the subtraction operation on binary numbers by borrowing numbers from the previous one. Okay. Now the next number is 100.001, 100.001, and the next number is 10.01. So it is 10.01. So you can find few blank spaces over here. So I am keeping 0 over there. Again I am telling you this, if you are adding 0 on the leftmost side of a number, it's not a problem. If a binary point is there, fractional point is there, and you are adding zeros in the fractional part of it at the rightmost part, then still it is not a problem. So 1 minus 0 is 1. Got that? 0 minus 1, again you have to borrow. So it will borrow from these, but these four are continuously 0. So definitely it will borrow from here. So it will borrow from here. This will become 1 0. Again a borrow. This will become 1 and this will become 1 0. Again a borrow. This will become 1 and this will become 1 0. Again a borrow. This will become 1 and this will become 1 0. So 1 0 minus 1 is 1. 1 minus 0 is 1. 1 minus 0 is 1. And now 1 minus 1 is 0. Okay. So the result of it is 1.111. And to verify, let's add it. 10.010 and 1.111. Let's add them up. So 1 plus 0 is 1. 1 plus 1 is 1 0, so 0 and 1 carry. 1 plus 1 is 1 0, so 0 and 1 carry. 1 plus 1 is 1 0, 0 and 1 carry. 1 plus 1 is 1 0. And after 3 decimal places. Okay. So 100.001, which was our first number. So hence, this is how you perform binary subtraction while borrowing numbers. Now another two ways for performing the binary subtraction are 1's complement method and 2's complement method. In your examinations perspective, if we will talk about your examination point of view, they will mention whatsoever question they will provide you to perform the subtraction, they will mention over there whether you have to perform with 1's complement or you have to perform it with 2's complement. In case if they won't mention the way you are going to perform the binary subtraction, it totally depends on you. So if you want to do with 1's complement and 2's complement, that is also possible. It totally depends on you. So now the next methodology is with 1's complement. But before I tell you how to perform 1's complement, let's take another number over here. But this time when the first whole complete binary number is smaller than the second one. Okay, where actually the difference is going to be a negative number. Like suppose I am subtracting 5 from 3, or let it be 8 from 5. So 5 is 101 and 8 is 1000. You have to perform this. Okay, how you are going to do that? So my suggestion would be, do the normal subtraction, that means subtract the smaller one from the bigger one. Note down the answer, whatsoever the answer you are getting. Okay, now suppose if I am doing it, so what will be the result? I have to take the carry, so this will become 10, and to give the carry 10, and to give the carry 10. So 10 minus 1 is 1, 1 minus 0 is 1, and 1 minus 1 is 0. So this is your result, 1 1. Okay, this is your result, 1 1. So you first of all perform the subtraction, subtracting the smaller one from the bigger one. Once you get the result, now the thing is whether you have to represent it in 8 bits or 4 bits. It totally depends on that. So let's suppose first of all I am representing it in 4 bits. Okay, so because I know that the result or the operation that I am going to perform, whatsoever operation that I am going to perform, it's going to be a negative number. So how do I add a negative number, or how do I write a negative number? So negative numbers are actually represented by a 1. So if the whole number is starting with a 1, okay, then of course it's a negative number. And if the whole number is actually starting with a 0, then it is a positive number. So since our result should be negative, so I will start with a 1, and I have to make a 4-bit number, so the next one will be 0. So 1011 is actually representing negative of 3 or minus 3. Okay, if I want to represent in 8 bits, so 1 0, I am having 2 bits already, so 6 bits I have to write, 5 6, and then 1 1. So this is negative 3 in 8 bits. Okay, well, in the next chapter we will study about sign magnitude representation, so don't you worry about it. Now let's see what are the other two ways to perform this subtraction. They are 1's complement and 2's complement. Now let's talk about 1's complement first. So what is 1's complement of a binary number? So it's very simple. Convert all the 1 into 0 and all the 0 into 1. That will become the 1's complement of a binary number. Okay. For example, if a binary number is there 10110, so its 1's complement, what it will be? Its 1's complement will be 01001. Okay. So I hope you understood how to get a 1's complement. Okay. So whilst doing the subtraction operation with the 1's complement, you will take the first number, you will take the second number, you will match their number of digits by adding zeros in the blank spaces. Once the number of digits are same, you will create 1's complement of the second number and you will add it with the first number. So what we have to do, you have to first calculate the 1's complement of the second number. Once you got the 1's complement of the second number, then you have to add it with the first number. The result of this addition will be the result of actual subtraction. And one more thing, while we get the result, that time I will tell you. So let's do a subtraction operation with 1's complement. So I noted down few numbers for performing subtraction. So let's perform subtraction on this. The first one is, so let's do the first subtraction. So it is 111 00101 subtraction 11011. Now first of all we will note down, suppose n1 is the first number, so 111000101, n2 is the second number, so let it be 11011. But we have to first of all make the number of digits same. So in the first number it is 3 4 5 6 7 8, in the second it is 5, so we have to add 3 zeros. So now both are 8 digits, okay, 3 4 5 both are 8 digits. Now you have to calculate 1's complement of n2, and let's name it n3. So that will become 111 00100. Now we have to add n1 and n3. So n1 will be added to n3. So that will become 111 00101, and this will become 111 00100. So now let's add them. Now the interesting part is you have to take care what is the result of this addition. If the result of this addition is giving you a leading carry, it means whenever you are adding them and you are getting a leading carry over here. Okay, so if you are getting a carry, that means the result of this difference is a positive number. And if you are getting no carry over here, that means result of this difference is a negative number. So totally you have to take care whatsoever carry is coming or not. So let's add them up. So 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 1 is 0 and 1 carry, 1 will be here, 0, 1 plus 1 is 0 and 1 carry, 1 plus 1 is 1 0, 1 0 plus 1 is 1 1, so 1 carry. Now 1 plus 1 is 1 0, 1 0 plus 1 is 1 1, so 1 and 1 carry. You can see you are getting 1 carry over there. Now this carry you will not write as part of the answer, because the answer is only 1 1 0 0 1 0 0 1. Now this is the answer only. But the carry is actually telling you that the answer is positive. Answer is positive. So I am telling you the steps one more time. Okay. If you are having two numbers, what you will do, you will first make the number of digits of both the numbers same. Then you will calculate 1's complement of the second number. Name it something like any variable, you can give it a name. So I am giving n3. So first 1's complement of n2 is n3. So this is the number. And how we calculate 1's complement? By changing all the zeros to 1 and all the 1's to zeros. That's it. Now you have to add this 1's complement or n3 with the first number. Now whatsoever result you are getting, you will get the result over there, but you have to take care about the carry. If you are getting a carry as the leading number, then definitely the result is positive, otherwise the result is negative. Whether you are getting a carry or not, you won't write. If you are getting a carry, if you are not getting a carry, okay, there would be nothing. But if you are getting a carry, you won't write it as part of your answer. Keep that in mind. So this was the methodology of 1's complement. Let's do one more subtraction with 1's complement, and then we will see how to do it with 2's complement. Okay. Now, the second subtraction number is, let's see this one, 101011 101011 minus 111001 111001. So number of digits 336 336. So number of digits is already same. So n1 let it be 101011, n2 let it be 111001. Now n3, which is actually 1's complement of n2. So it will be 000110. Now all that you need to do is n1 plus n3. You have to add these two. So that will be 101011 and 000110. Just add them up. So it is 1 plus 0 is 1, 1 plus 1 is 1 0, so 0 and 1 carry, 1 plus 1 is 0 and 1 carry, 1 plus 1 is 0 and 1 carry, 1 and 1. So hence you are not getting any carry, no carry. So result is negative, So this is how you are going to check or perform the subtraction operation. Now let's do the subtraction with 2's complement. Okay, so before that, let's see how to form 2's complement of a number. So it's very easy. You learned how to form 1's complement, right? Adding 1 to 1's complement, will provide you 2's complement. Okay, so let's do with 2's complement. Suppose the number is 111000101 minus 11011. Now the interesting thing is, the way of performing the subtraction is same whether you are doing 1's complement or 2's complement. The only difference is whether you have to calculate 1's complement or you have to calculate 2's complement. So that's the only thing that is different. So let's do it. So let's note down the numbers and let's make the number of digits same. So this is the place where students commit mistake. They don't make the number of digits same, right? So 1 2 3 4 5 6 7 8, and here is 5 only. So 1 2 3 1 1 0 1 1. So we have written the number. Now we have to find out 2's complement of n2. So 2's complement of n2, and let's name it n3, is equals to, so first of all we have to find out 1's complement. So it will be 111000100, and we have to add 1 to it. So it will become 111000101. Now we have to add n1 with n3, right? So it will be 111000101 added with 111000101 itself. Okay, fine. Okay, same. Actually we are getting the same. I know it's just a coincidence. Okay, fine. Let's add them up. 1 plus 1 is 1 0. 1 will go carry. 1 plus 0 will be 1. 1 plus 1 is 1 0. 1 will go carry. 1 0. 1 plus 1 is 1 0. 1 will go carry. 1 plus 1 is 1 0. 1 0 plus 1 is 1 1. 1 will go carry. 1 plus 1 is 1 0. 1 0 plus 1 is 1 1. So 1 and 1 will go carry. So this carry is telling this subtraction is giving you a positive result. So this is how with the carry, whether you are getting a carry after the addition of the 2's complement or 1's complement, tells you that a given number is positive number or a negative number. So with that you can easily tell, or you can easily perform the binary subtraction. Now the last arithmetic operation with binary are binary division. Now to perform the binary division, of course you have to perform binary multiplication and you have to perform binary subtraction. Both these arithmetic operations we have already seen. Now let's move on to binary division part, and that's our last numbers arithmetic part. So all that we have to do in the arithmetic part with binary numbers, we have completed it. Once we completed this binary division, I have also noted down few questions for your exercise, which I will tell you at the end of this video, which you can note down and you can submit it. In case if any of the question is you are unable to solve, then you can click a photo of that question or your solution whatsoever you have done, and you can submit it as your query, and we will solve it in the next video lecture. So let's do the binary division. I'm just showing you the division operation because it is combination of multiplication and subtraction. So let's do it. The first number we have to do is 11011 divided by 11. So it is 11011 divided by 11. Okay, so we'll simply multiply 1 with 11. So that will become 11 itself. Now you have to perform subtraction over here. So this will result into 0. Now 0 will come from top. Of course you can't perform anything right now. Okay, so you will simply write 0 over there. So one more 1 will come. Okay, and simply you cannot perform anything right now also, because earlier it was 0 0 and you cannot divide 0 by 1 1. Now the value is 1. You cannot divide 1 by 1 1. So again you will put a 0 and one more 1 will come from top. Now 1 1 multiplied by 1 will be 1 1, so it will result into 0. Now you can check it out whether you have done correct or not. So 1 0 0 1 1 0 0 1 1 0 1 1. So you get your result 1 1 0 1 1, right? So you can check it out. This was the multiplication. You can easily check it out whether you have done the correct division or not, right? So the laws are very simple. You have to multiply the given number with the number given dividend with the divisor given over there, and then you have to perform the subtraction. If the dividend whatsoever you are getting here is smaller than the divisor, definitely will put a 0 and you will get the next digit. Otherwise you will put a binary point and you can add a 0 over there. Let's see one more division, like 101, and this is our last question for today's video lecture. 101 111 01, sorry, 101 1101 is actually multiplied by 10 divided by 101. So if you multiply 101 by 1, okay, if you will multiply 101 by 1, you will get 101 itself, and if you will subtract it, it will be 0 finally. Now 1 will come from top. Of course you cannot do anything right now, so we will put a 0 over there. Another 1 will come, again you cannot do anything, you will put a 0 over there. Now 0 will come. Now you can do, definitely you can do something. So 101 multiplied by 1, so it will be 101 itself. So definitely again you have to take borrow, sorry, you have to take borrow, so this will become 0 and this will become 10. 10 minus 1 will lead to 1, 0 minus 0 will be 0, 1 minus 1 will be 0. From top it will come 1. So now definitely 1 1, which is actually 3, cannot be divided by 5. So you have to end it over there only. And you can write it as 1011 101 is equals to 101 multiplied by 1001 plus 11. So if you perform this operation, you will get this. Now today we have discussed about binary arithmetic, binary addition, binary subtraction with borrow, binary subtraction with 1's complement, and binary subtraction with 2's complement. We have also learned binary division along with binary multiplication. So all the binary arithmetic we have dealt today. I have shown you few examples over here. I tried to solve it, and I tried to tell you the pitfalls where generally student get fall. So I hope now you understood this, and now you will perform these exercise questions which I made for you. So please solve these questions. In case of any problem, you can raise that by clicking on the link given in the description below. Please utilize that link for raising your doubts, and that's it for today's video lecture. Hope to meet you in the next video lecture. Till then, thank you and have a nice day.